5, 4, 3, 2, 1. Hi everyone, I'm really excited to host Jeroen van Lith, founder of PlanFinder, a software plugin to draw plans quickly.
Thanks
Jeroen,
for having me.
I'm very excited to have you on the show. I highly recommend to check out uh, PlanFinder, and when I saw it, I immediately asked Jeroen that I should interview you. It's an amazing work, so thanks a lot for being on the show.
Yeah, I mean, I've seen your show for quite often, and I really like it. So I'm really happy to be a part of it as well. Thanks.
Thank you. So, Jeroen, can you walk us through some highlights from your career till date, and uh, also talk about your background, where you grew up, and out of all things, why you chose this profession?
Yeah, good question. Yeah, so I come from the Netherlands, and I had quite a typical architectural career path. I studied architecture at TU Delft in the Netherlands, and during my career, I got kind of interested in Grasshopper a little bit, and then started doing internships. So I interned at like Lava, it's kind of the deep like architecture, and OMA in Rotterdam. And yeah, I was an intern and I couldn't really choose which project to work on, but they put me on a lot of housing projects. And so I had to draw a lot of housing plans. And I think that was kind of forming for me, or that was kind of becoming a frustration later on. But yeah, let's keep it at that for now. So I graduated architecture school, and then started working as an architect at Hen in Berlin, which was super cool. But that kind of that itch of those housing plans, which I had to draw as an intern, kept kind of bugging me. So I then decided, okay, I'm going to try to do some Python tutorials. And I tried it like for 10 or 20 times. And then at some point, I just realized that I needed to take it more seriously. So I went back to school, did a second master degree in computer science. And yeah, that really gave me kind of the kind of confidence and the kind of background to program a little bit easier. So after that, I worked for around 2 years as an AI researcher at a Dutch research institute. I worked a lot on GIS data and so forth. But kind of the idea of like the floor plans, that kind of problem which I had as an intern kept kind of bugging me. So I knew that like in the end, I want to work on this. And so for around 2 years now, I'm working full time on PlanFinder.
This is awesome. And uh, can you talk about like the initial days of PlanFinder, like how you started and what were the challenges in the development? And yeah.
Yeah. So first of all, like I had scripted something in Grasshopper, and I thought that this would already be working fine. And then I started to test it with a client of mine, and they just really didn't like it, and they wanted a lot of other options. And I quickly realized that Grasshopper really wasn't the way to go. So it was a lot of programming, and I think in the end it taught me that it would be good if I could create programs which are flexible enough so that I can reuse them later on, and I can also implement some requirements or new requirements of the client. So that was something I really learned at the start, for sure.
I see. And I'm very curious to know your thoughts that how has your perspective being changed when you had architectural background versus
Mm-hmm.
software background towards AEC?
Mm-hmm.
Do you look
Yeah.
at things differently now?
Yeah, I mean, I think what was super strange for me when I was studying architecture, it's all about like design, and I don't know, like people are, it's kind of, it's not so rigid profession. So, or like the approach is not very, not often very scientific. Whereas computer science was like super scientific and all about numbers. And that was like for me quite a cultural shock. I had to write my thesis and suddenly it was all about numbers, whereas architecture you could literally like write poetry and it would be fine.
Yeah.
So that was kind of a real culture shock for me. But I think in the end, as I really like architecture and I love architecture design, but for me personally, like the computer science part fitted me better. But I think it's nice that I can now do both. So I can now like and care about buildings and think about buildings all day, but more from a kind of computer sciencey perspective.
I see. And lastly, before we do a deep dive on PlanFinder,
Mm.
what if someone is interested to to learn software development, but they don't have like time or resources to pursue a computer science degree? Like, what are
Mm.
few courses you recommend them for sure to to study?
Yeah, so my computer science degree was a kind of generic computer science degree, which didn't really capture everything I was interested in. So I did quite a few Coursera courses as well. And one I particularly liked was like a machine learning course of the University of Michigan. Maybe we can put a link in the description later, but that was kind of a really simple way in which you could start trying to do some ML experiments with scikit-learn and with very small tabular data sets. So it was like, it didn't require like massive GPUs or something or massive deep learning models, but it was a very easy way to start understanding things like training and testing and all these kind of basic concepts of ML. So that's definitely a recommendation. And I think the other recommendation, but that's kind of, I think people say that more often, but I think it's very true that it's also, I think, important to just work on some project for yourself, because if you're only doing the tutorial, then you never really, you never really find out about the things you really need for your own project. So I think it's better to just work on your own project and think about something which you care about.
It's awesome. Yeah, I think I have checked out that Michigan course. It's really good. Yeah,
Mm,
definitely. If you know the like things you want to do and trace back what are the things you want to learn, I
mm-hmm.
think you definitely can find some YouTube tutorials or some Coursera to achieve that.
Yeah,
So,
totally.
uh, Jeroen, can you walk us through in-depth overview about PlanFinder?
Mm-hmm. Yeah, shall I do it with the presentation or do you want that later?
Yeah, let's do with the presentation.
Cool. Share.
Perfect.
Cool. All right. So, I mean, I've already talked a little bit about my background, but so I will not, I hope I will not repeat myself too much. And if you have any questions, by the way, just feel free to interrupt me during the presentation, of course. Um, so I have a background, as I told you earlier, about in architecture. So TU Delft, Lava, OMA, and HEN. And yeah, something which occurred to me was that I had to draw a lot of housing plans. And I just noticed there was a lot of similarity between the floor plans I was drawing. You know, the first one is very interesting, but if you've drawn 10 or 20, you start to find out the similarities. And why is that? Well, it's because like in different countries, you have different regulations. You have, costs, so you can often not make super expensive apartments. And you have a certain culture of clients just wanting things. We want 2 bedrooms and we want to study and those kind of things. So together, that makes that very often floor plans don't look that special. Maybe one floor plan for a billionaire, but the other 99% of the floor plans look quite normal or quite similar to each other. So that was something I just found out when I was drawing all these plans. And so I was really kind of thinking, like, I'm just kind of reinventing the wheel the whole time. I'm always drawing these plans, but they're actually always quite the same. And as an architect, you have to work on many things. It's not just plans. You have to do presentations, you have to do communications, you have to check out the zine, you have to do all these things. But some tasks within that architectural design, in my opinion, felt a little bit repetitive. And yeah, drawing housing plans felt like one of them. So it kind of like was an itch for me, like, shouldn't there be a way in which we can do this a bit quicker? And so I was thinking, like, can we leverage what we've drawn before? Because that was another thing. You know, I was working in big firms, and then you would like kind of awkwardly look at old projects, and you would think like, oh, can we get some floor plans from there? And then you would have to guess which AutoCAD file you would have to open, and then kind of hope that your AutoCAD won't crash, and all this kind of, you know, not imperfect ways of leveraging what you've been drawing before. So I was thinking like, yeah, it would be nice if we can, in a more structural way, learn from what we've done in the past. Yeah, almost like academics, like we could like reference existing work, you know, rather than starting from scratch. An academic would never start from scratch each paper. And maybe as architects, like maybe it would be cool if we can reference existing work, and from there on, you know, focus on what's really creative and really kind of build a higher level. So that was kind of the idea behind it. And then I started Grasshopper prototyping my idea. So and I quickly found out that Grasshopper is really great, but if you start to draw a really big software, then, you know, Grasshopper doesn't want to play anymore. So that was kind of like, I experienced that myself. So I thought, okay, maybe I should go more towards computer science or programming. So yeah, I went from Grasshopper to programming. And then when I started studying computer science, what was interesting for me was, I think it was a tweet from Andrej Karpathy, head of AI at Tesla. And he tweeted like that machine learning was the software 2.0. Because with machine learning, you didn't have to write the program anymore. You would just give it some data, and machine learning would create the programming. So it was really this kind of meta programming. And I thought, I want to automate something, and machine learning automates what I want to automate. So it would be best if I focus on machine learning during my studies. And it was also like, it was like when I started studying, it was like 2016. So it's like the kind of the, you know, deep learning was really taking off, and there was a really hype. It was like Web3 is right now. So it was deep learning in 2016. So it was kind of the hype as well, but it was just for me very interesting back then, and it still is. Yeah, that's all kind of resulted into PlanFinder. So what is PlanFinder? Well, you might know it from our previously built COVID-19 planner. You can find this is like a software plugin for Grasshopper, and what it does is basically two things. It fills tables in spaces while maintaining a certain distance, and you can also assign like chairs within existing buildings to also maintain a certain distance between chairs. And this was really, for us, a kind of quick way of dealing with the new requirements which COVID brought us. And you can also try it on Hypar. So yeah, if you want to try it out, it's for free, and you can check it out on Food for Rhino or Hypar. And but what we really mainly focus on is our software plugin to draw apartment floor plans quicker. So it's a plugin for Rhino, Grasshopper, and Revit. And it does two things. One, it fits plans, and the other one, it furnishes plans. So those are the only things it does, but it does them, we focus on it. It does that really well. So first, I'll talk a little bit about the fit functionality of the software. So it's basically like Tinder for floor plans. So yeah, just like Tinder, you can filter on your own preferences. So you can filter on like the amount of bathrooms or bedrooms you want to have in your floor plan. And it's basically based on an existing library of floor plans of collaborating firms, so that like we can reference them, and then we can use them in new designs. And the library looks a little bit like this. So you can see like all sorts of different plans, different shapes, and they have different, you know, amounts of bathrooms, bedrooms, all sorts of things. And yeah, the idea is really to grow this library as much as possible, so that, you know, for every country, there's an interesting floor plan which you can reuse. And so how does this fitting work? is basically like we derive the form of those plans. And then, you want to design a new floor plan, and you've drawn this blue rectangle on the left bottom, and then the algorithm will just match match that rectangle with all the other shapes in the library. And according to that match, it will then score it. So if it's like almost the same shape, it's very happy, and if it's not, then it's not so happy. But so it's actually it's not really rocket science. It's just a kind of easy way of sorting out or ranking the libraries in the library, the floor plans in the library, and then it just gives you the best option. It returns you the best option. So here's a kind of small animation of how that works. Hopefully, it will just do load, it seems. Let me see. Oh. Let's try it again. I'm not sure if the animation is, it says my internet connection is unstable.
Oh, maybe like your bandwidth is being used on Zoom.
Yeah. Okay, maybe we can try it later on. That will now go to the next functionality.
Yeah, even like I can share if it's on YouTube.
Cool.
Yeah,
it's it's also on my website. So it's on PlanFinder.xyz. It'll be cool.
Yeah, I have the website, so yeah. Oh, you want me to share it right now? Okay.
Yeah, if you could, like, I mean, I can also check out.
You can see the website, right? Can you see my screen? Hello?
Yeah, so if you scroll down a little bit, so here you can see how it works. So you basically have to, you enter a polygon, and then you enter a point, and then you can basically click through the options. And you can then also like filter on more specific options like amount of bedrooms or bathrooms. And thereby you can kind of really quickly get an idea of what is more or less possible within the space. So the idea is not to create the perfect plan or to create like the final result. That's really up to you, but it's more that you get a very quick idea of what's more or less possible. And because I was talking earlier about this idea that within residential apartment floor plans, because of regulation, cost, and all these things, there are just not that many options possible. So that was also kind of a motivator for me, that like, if you need a certain amount of bedrooms or bathrooms and you have a certain shape, then there are not that many options possible. And so what this does is it gives you a few options, which you can then kind of use later on in your design process, or very early on in your design process, where you get a quick, rough understanding of what's more or less possible.
This is great. Like I loved how you manage the whole UI UX experience and how frictionless it definitely justifies drawing plan faster. And I'm
Cool.
assuming like you have this polygon, so the start of the polygon determines the entrance of the apartment.
Yeah, so you actually have to assign like a point on the polygon which you want to be the entrance. So you can see like in the interface you can see like a blue dot. I'm not sure if it's visible in the movie, but yeah, you have to specify the entrance, and then the algorithm will look at how do I have to rotate the plan so it will be closest to the entrance.
Got it. And what if the plan matches, let's say, a rectangular plan with a rectangular plan in the data set,
Mm.
but the number of rooms or bedrooms doesn't match? Like, how
Yeah,
does?
then you can filter. So there's like in the UI, there's like on the right top, there are some filters. So you can filter on the amount of bedrooms, bathrooms, or that's what we're doing here. And then you can also filter on country, for example. And that's another thing, like, you know, floor plans are always different in a different country because of regulation and all these kind of things and shapes. So that's another thing which I think is quite useful, that you can then also filter on specific country.
I see. That's so. There would be like no, like, not available output. Like for all the filters, it will generate some output.
No, so there's we have around 500 floor plans in the library. So if you have a very strange form, or you have a country from which we don't have any floor plans, then it cannot return any floor plans. So there, in that regard, it's a little bit limited. We're now focused on mostly European plans. We do have also some plans from the US, but in that regard, it's still a little bit limited. But because we want to, or we are expanding the library, we hope that this will get better every month.
Yeah, and maybe like if more users are using this tool and they are modifying the plans, there could be an upload function where you build up the library from the end users itself.
Exactly. Yeah.
That's awesome. And I'm curious to know like about the normalization. So in the data set, like how did you like, okay, I'm assuming like all the flow plans are in image or raster format. So what was the
No, it's
process? Yeah.
actually just a geometry. So we just do, it's like from a machine learning perspective, it's a nearest neighbors algorithm. So you have
Uh-huh.
like all the geometry, and then you have the input geometry, and then you look at shape similarity, and then you also look at the distance between the entrance of your target and the library floor plan. And then optionally, you can also look at the facades. So there's also functionality in PlanFinder where you say, okay, I have this corner apartment, so it has like a facade on the whole corner, and I want to specify that all the plans which PlanFinder return are corner apartments. So you can also specify that. And then with those three geometrical starting inputs, it will then generate the first batch for you.
I see. So on the machine learning side, we are just comparing the exterior shape of like there are different shapes.
Yeah.
All right.
It's
So
very simple. It's really like you have a library of floor plans or a library of polygons, and then you just check the shape similarity, and then you just rank them according to how well they are, or how similar they are.
I see.
And we do some augmentation, of course. So you have to reflect the plans, and we rotate them as well, the library plans, so that you generate more options. And we also scale them a little bit, and we translate them a little bit as well, so that the fits gets better.
Yeah. Now I think I got most of the picture. I'm still, I haven't used the shape similarity before. So like, how do you train it? Like, what's the
that's the
an
thing. Like
input? Yeah, or it's just mapping.
This is not trained. So it's literally like a nearest neighbors algorithm. So it's like you have some target shape, and you look at your data set. What are my most similar shapes, and that's it. So there are no weights. I mean, I can talk about machine learning or about some trained models later on. For Furnish, we use supervised learning and all these things. But here we mostly use just the nearest neighbors algorithm without any weights. Or yeah, we weight. The only weights are in our scoring function. How do we score our function?
Got it. And the input is the whole shape and like what format it is.
Yeah, so it's like an input is a polygon and a point and an optional list of polylines for facades. And then it will just look at all the data in the library. It will just, for every floor plan, it will look how similar am I to this floor plan? And it can be just like distance. And then you sort all the floor plans in the library according to the smallest distance. And then you return that to the user. And then you show that. And then the user can from there on kind of interact with the app.
I see. And like the reason I asked is like, if let's say we have image similarity or like those different similarity, like the input data is in very high dimension, and then we project it to either smaller dimension and then do mapping and comparison. So that's why I was thinking like the polygon data could be very high dimensional. So to do like each line in that polygon is like rows of data. So do you map it 2D?
So we intentionally keep it like very, in a way, like low dimensional, or we don't create some sort of other representation than the raw geometry. So it's like we have this composition of a geometry, which is like the entrance, the polygon, and the facade. And then we can calculate directly the match with the floor plans in the library. So we don't, if you do deep learning and you want to do like image similarity, then of course you cannot get such a clear descriptor of your cat or of your image of a cat, right? Because how do you clearly define that? But with our geometry, we can very clearly define what the input geometry is. We don't need a different representation to match.
Got it. It makes a lot of sense. That's great. Do you want me to stop sharing?
Yeah, cool. So I mean, we can try to continue with my presentation. Let me just quickly share my screen again. Let's see. Oh, you can still see my presentation, yeah, or my screen?
Not yet.
Okay. Let me see. Share screen and then. Yeah, and then. So for like PlanFinder, for us, the conclusions of this fit functionality really are that you get a quick insight in the possibilities. So it's not really about, I mean, I told about this earlier, but it's not really about that you generate a final plan necessarily. It's more that you get a very quick understanding, okay, this is more or less possible, and that's more or less possible, and everything in between, but you also know that other things are not possible. And I think an implication of this, and this is something which I didn't really think of, but something which a client told me, is that this also allows for a more direct communication to the customer. Whereas like previously you would need to get some requirements as an architect, you would work on your floor plan, and then the next week you send a PDF with the drawn floor plan. With PlanFinder, they can very directly interact with the client and interact what roughly the possibilities are. And then, but this can also happen in your firm, of course, where you maybe talk to your the project architect, and you want to quickly kind of interact about a certain design possibility. But because there are so many options which you can immediately generate, it really allows for more direct communication. And yeah, the fits are improving every month because as we get more customers, we often make a deal that they get discount, but then they add some plans to the library. So then the software also becomes better. And then
can I ask one more question?
Yeah.
So currently, like in the plugin, is it fully deployed on the edge, or is it making like API calls to your server?
No,
to do matching?
it's run fully locally. So it's just everything runs locally.
So all the shapes are packaged inside the plugin for comparison.
Yeah, all the library is all in the plugin itself. So there's no AWS Lambda calls.
Awesome.
Cool. All right. Then the furnish functionality, and that became a little bit kind of first like an internal tool, but then we realized that it's also useful to make this a part of PlanFinder. And that's really the problem of when you already have the walls of a certain plan, and you just want to create a nice furnished plan with furniture in it, with walls in it, with rooms in it. And you only have the walls. So how do you do that? And when we were drawing like plans for the library, we realized that we every time we have to furnish the floor plan, and that felt a little bit like a repetitive task, like drawing floor plans, but then on a more granular level. So we thought of ways, how can we also furnish a plan automatically? So Furnish now furnishes a plan automatically, and it's customizable and overridable. So I mean, that's something which is kind of most important almost in PlanFinder, that like everything we suggest are obviously it's not the final design, but it's only a suggestion, and you can always override it. So how do we do this? How do we furnish plans automatically? So we first do like a room classification. So we like you mentioned earlier, we now actually translate the plan into a raster, multiple scales as well. So like on 0.2 meters, 0.4 meters, 0.8 meters, and so forth. And then we kind of make like one-hot encodings of. I mean, it's very technical. Maybe I'll skip this for later. But we do room classification. Then we do door classification. So if you have the rooms and you have the functions, then you also have a pretty good proxy of where the doors might go. And then you do furniture generation. So like you start from room classification, then okay, this is the living room. Then you from there on can reason about, okay, where should the doors then be? And then when you have the doors and the rooms, you can then generate the furniture. So it's like 3 steps basically. And now it's gonna probably fail again. Oh no, it's not. Oh great. So this is an example of furnish functionality, where you have to give a little bit more input. So you have to give the facade, which is happening right now, and the interior walls and the entrance point. And then it will generate the options for you. And you can always override it. So if you want to change like the door or of a wall, or you want to change the function, then it will change that. And if you click on a room, it can also generate like multiple options for the furniture layout of a room. So that in that regard, it's also a little bit flexible. And then you can bake it in 2D and 3D and so forth. And then you end up with a plan which is basically roughly finished, but you can then extend it to your own needs. And I think like in general, like maybe to conclude, like what we want to do with PlanFinder is really to leverage all those existing drawings which we've already drawn before to really accelerate the design. And in the end, so that we can design things quicker and have more time for other important things in the design process. And if you want to try it out, you can request a trial for the Rhino, Revit, or Grasshopper plugin. So that was a short presentation. I hope you have some questions.
No, that was great. Like, I love it. And
cool.
If you can go back to the slide or the presentation where like you were showing for the classification.
You mean here, or
I think it was in the demo, but there was like a user interface which was very interesting. Like when you selected, it prompted, and there's also when you hover your mouse over it, you could
Mhm.
see and modify it. So can you
Yeah.
elaborate a bit more on how you develop this aspect?
Mhm.
I'm guessing it's like Windows presentation format and
Exactly.
yeah.
I mean, to be honest, like it's yeah, from a kind of UI perspective, it's indeed Windows presentation framework. It's just it was the easiest way to work with both Rhino and Revit in a kind of more presentable way. I don't exclude that maybe in the future you can also use this on the web, but right now it's yeah, it's really a plugin for Rhino and Revit. And in Grasshopper you have different, yeah, it's just components, so it's not really like an interface. So I'm personally more a fan of Rhino or Revit versions because you can really quickly override any suggestions of PlanFinder.
Got it. Yeah, I was about to ask like it's very smooth and fast. One could also do web-based and
Yeah, yeah,
operate it
exactly. I
from
mean,
phone. Yeah.
yeah, there's so many really cool things happening right now. It's only that like, you know, we have limited resources at PlanFinder, and I don't want to personally like build a whole kind of or do all the graphics and reinvent the wheel for the web. So we probably will use like an existing software to present PlanFinder in the web as well. But it's definitely possible and would be really cool.
Yeah. And you mentioned about integration in Hyper for Find. Like,
Mm-hmm.
how does that work?
Yeah, so for our COVID-19 planner, we developed two functionalities. So we developed like a chair picker, so it can like pick chairs with an existing building, but it can also fill a room with tables with chairs. And then within or between those tables, you have like you can take into account some sort of distance requirement. And we also uploaded that to Hypar. It was actually like super easy to connect to that, and it was really cool to see your own code in the web. Yeah, super cool.
That's awesome.
Mm-hmm.
And breaking down, so you showed that there were three classification.
Mm-hmm.
So, and you mentioned about converting this geometry into raster.
Mm-hmm.
And I guess like the next step was to label and tag all those like doors and rooms. Like
Yeah.
that data set tagging itself is a huge another task.
Yes.
A- And
Yeah.
then like
Yes, exactly. The thing is like we do need to transform the existing data into our own data format. But then once we have that, we can really quickly iterate on it. So, also in our software, we have like a rasterization algorithm, which then we can use to generate, bitmaps of our or rasters of our floor plans really quickly. So, yeah, we do but the labeling, the real drawing of the floor plans is done, or of our library is right now done by hand. But I think like with enough data augmentation and you can actually train machine learning models also on smaller data sets. So it's not that I'm afraid that the rest of my life I'll be labeling like floor plans. I think with the right amount of data augmentation and yeah, just trying to be clever with some tricks, you can go pretty far.
got it. And you have like a bake rooms option. So is it on this UI we are currently playing on? Like I'm having a bit of hard time in understanding the inference pipeline. So you got the geometry into this WPF. Right now it's in vector, but the inference is on raster level.
Yeah.
So you get the output and then again you convert from raster to vector.
Yeah, so what we do is we get the input, and then it's basically a bunch of walls and a facade and an entrance point. So it's very sparse input. And then what we do is we in a 2D plane one hot encode it. So like we make a raster of each kind of semantic layer of the floor plan. So like you have like facade, you have entrance, you have internal walls, room bounding walls, non-room bounding. You have all these different semantic entities of the input, and that you then and then you go for each room. You sample like a rectangle from that raster, and then you do a multi-class classification, and then you get like that's an example for the room classification where you then have the probabilities of a certain room, and then you can then use that to actually classify the room.
Yeah, and once those rooms are classified, and right now I have the filter option of changing bathroom to bedroom. Like when you are doing that change, what request it's making to first of all call that, okay, change the furniture layout because the room category has changed, and where it's getting the new furniture input from? Is it like a map of library that, okay, take a bedroom of this size, populate it with furniture?
Yeah, so I think the main strategy behind, I mean, furniture algorithms are a little bit different for each room. For the toilet, they're not so sophisticated, but for a bathroom, for instance, they are. So what the idea is a little bit is that like you have a certain room, and or PlanFinder suggests a certain class to the room. So like let's say a bathroom, or you say from the user you get an assignment of this is a bathroom, or I want it to be a bathroom. Then the next step is to do like a set classification of which furniture elements will be in that room. So like it's again like a multi-class classification problem where you give the rasterized inputs of the room, and then you can do like a set classification of like, oh, there should be a bath in here and a sink and a toilet, or maybe it's a Dutch floor plan, and in the Netherlands we don't often have like toilets in the bathroom. So then it will suggest, I hope it will suggest that there won't be a toilet in the bathroom. And then you have like an X amount of sets which with their probabilities, and then you rank them according to the highest probability, of course. And then from there on, you can run a furniture generating algorithm, whether it's manual or procedurally generated, or have some deep learning algorithm behind it. Doesn't really matter, but then you can run that later on.
That's awesome. Yeah, I'm just wondering, like for the architecture or AI enthusiast, it would be interesting if there's like a model architecture diagram or data flow architecture. So like you will get like a good sense of like how it's getting started, and then once it's trained and deployed, how is the inference pipeline? So
I mean also like from a, maybe to clarify a little bit, like from a technological point of view, we do most of the things in C#. So we we have all the plans we can read into C#, and then we can export that into text files or whatever, and then we do the machine learning training with TensorFlow or Keras, and then once we're done with the training, we export the machine learning models to C# code, so that you can see basically a neural network as a directed acyclic graph of some layers, and then we just like export the layers with all the weights, and then you can just like from C# you can then read them in, and then you can run the inference from there. So it's mostly just C# code. It's actually like when a user is using PlanFinder, they're not running some other ML model. It's just all C#.
Oh, like I think that clarifies. I was assuming on the lines that, okay, once you have the trained model, the format, you might need like Iron Python or Hobs server.
That was like I felt like that was maybe a bit annoying, because then you have to go, have to make another call and all this kind of infrastructure which comes around that is kind of annoying. So in the end, like it's just some matrix multiplications in the in every layer in a neural network. So we just, I mean, from Keras, you can just quite easily get the weights of a neural network, and then we export that into JSONs, and then you read the model into JSON, and you do the inference in C#.
That was very smart. Like that, I think I haven't seen like people doing that. because a lot of people I talk when they are doing machine learning in Grasshopper Rhino environment, either they're creating one Python inference server and then
Mm.
sending data for inference and receiving it from
Yeah.
that, because like C
Yeah.
sharp doing machine learning, there's like not a good framework or pipeline C
Yeah.
sharp
So
based.
yeah, exactly. So that's a little bit like I just want to use like best practices, and with NumPy and all these kind of very cool Python libraries, like it would be a waste to like reinvent the wheel for all these things in C sharp. And also, I mean, all the kind of hyperparameters of machine learning models are really nicely tuned often in this default packages, TensorFlow and stuff like that. So, I just want to appreciate those things, and then once I'm done training, then a little bit of code to export the model into C sharp. But once you're done with that, you can then run it natively.
That's awesome. And uh, I'm curious, what were like some on higher level like challenges in terms of if you had any issues where the validation set or the testing accuracy, something on those lines where not, and are there any strategies you adopted to increase the accuracy for prediction?
Mm-hmm. Um, yeah, I think what is really what was something which was really useful for me, for example, was to because normally when you do like an ML tutorial, you have to think about, okay, how do I represent a plan in RGB image or something? But then I was thinking like, yeah, but a floor plan, it has all these semantic layers. It's better to actually not represent them in a geometrical, or not represent different entities in a different geometry. So it's like I was rasterizing the facade in a kind of very thin line, and then the internal walls as even thinner lines. And I was trying to be very clever, but I figured out like it's much easier for me to just like in a 2D plane in one raster, just one hot encode them, and then like have all these different slices of the plan with different entities. And that's something which a computer can very easily learn from, but it just was a little bit of kind of a different mindset for me, that I could actually see an image as a not just a three-dimensional array of 2D images, but a very high-dimensional array of inputs.
Yeah, and that's quite insightful because we lose a lot of semantic information like in this conversion. And I was
Exactly.
having a discussion like in the Hyper Discord that, about like using natural language and
Mm-hmm.
GPT-3 codecs
Mm-hmm.
to generate like code and stuff. And I just had a thought for this. Like there are many like algorithms. I think Theodore developed one semantic where you could type make a 2 bedroom, 3 bedroom, and it will generate some outline.
Mm-hmm.
And what if we could connect those with this, and it could
Mm-hmm.
be like a very interesting pipeline where I can do natural language, it will generate the shape, the
Mm-hmm.
finder will map the shape, and
Mm-hmm.
the furniture will like do first intuitive iteration of how the layout looks like. So just from natural language I developed like very high detail flow plans.
Yeah. I mean, I think it's a super cool idea, and I think we've all seen the avocado chair or the avocado chair created, and yeah, it just really shows that transformers are really capable of a lot of really difficult problems. And you know I think we also have to be humble, like this is not like generating floor plans is very difficult, and right now it's not, in my opinion, not solved yet. But I think transformer models could bring us there totally. So yeah, I think it has a lot of potential.
I see. And what's on your roadmap, and like uh, what would PlanFinder look like by 2023?
Mm-hmm. Yeah, so I mean, I think the kind of nerdy roadmap of us is that we want to generate floor plans, right? That's the coolest thing if we can do that. So that'd be, from a technological point of view, that would be really cool. And then from a from a more product point of view, it would be cool to make the product more widely accessible. So right now it's like really focused on architects, but it would be cool if anyone could use it, not just architects. But so that would require probably another layer of simplicity of the software, and maybe probably a web component to it as well. But it would be really cool if you can really make it super simple to use, so that anyone can, you know, whenever they want to do like a renovation in their house or something like that, they can really quickly or really easily use PlanFinder to get some ideas.
Got it. And how big is your team?
Yeah, so right now we're the largest floor plan generation company in the world, but since there are not so many, we are really small. So now it's mostly me, and I get some help from some freelancers. So yeah, it's a really small company, and also, you know, we don't have like thousands of clients or something like that. We have a few clients, and we are kind of gradually growing. So we're not a very large company right now.
That's awesome. Like the amount of stuff you have developed, it's very impressive.
Mm-hmm.
And you said you started like 2 years ago?
Yeah, so I mean, I was thinking about the problem for much longer, and like I think I made like a version of it in 2016 or something like that, or 2017. So it was always in my head a little bit, but right now, because I can work full time on it, I can focus on it much more.
And is it fully bootstrapped?
Yeah, totally.
Oh man, that's great. That's impressive.
Yeah, I mean, also, I mean, yeah, money-wise, I'm also sometimes like working as a consultant or something to kind of, you know, to still generate enough money. But so to not get you to let you get the idea that I can just work, or yeah, I mean, I have to get paid, of course. But no, I mean, in general, right now, I'm just working on this full time. Yeah.
Got it. And are you looking for any seed funding in future?
Yeah, so it's something we don't exclude. So it's like, yeah, would be quite interesting maybe. I think there are pros and cons to this kind of stuff, and I think if you can have like really interesting investors who are really aligned with you and can give you really good suggestions, you know, can really be teammates, and it could be totally a cool option for sure.
Yeah, because like the best part is like the amount of time it took to generate the plan. It was such a frictionless experience. And I'm also thinking on the lines like many times interior designers like sketch out like rough rooms, and like what if in that iPad or it's quickly generating those output, and they can go through design iterations. And the next level is like once we have those furniture output, what if we can connect in an AR app and like some projection where I have a slider and I'm iterating through different options of this, and I could visualize it spatially in a room.
Yeah, exactly. Yeah, totally. No, so I mean that's definitely an option, and I think, yeah, I mean, like we're also focused mainly on housing, because I think like that's also something where you can go like, you know, we only do apartments right now, but you can also focus on, you know, on freestanding houses, villas, or all these kind of typologies as well. So I feel like for my own career, like this is enough right now. And you know, there's so much, like you say, there's like so much to explore. Like also stuff like, you know, these furniture elements, they're kind of dummy things which architects always use, right? Like just more simplified versions, but in the end people use real furniture. So it's another cool idea to kind of, you know, connect real furniture suggestions to the software, so that you can get a more realistic idea of what's possible.
Oh, I was just thinking, since like this is an early design stage and iterative, like what if there is a small tab in this interface which gives like some analytics, or or some graphs, room size, bar chart or pie chart, or furniture, and like some quantity takeoff, like to get like, oh, this is how roughly the distribution of the plan is. And then if the bedroom or living room is too big proportionately, maybe move the interior walls and do again next iteration or something.
Yeah, Yeah, it's a really cool idea. I think it's also quite possible indeed that you can kind of give suggestions of like normally maybe the bedroom is little bit smaller, so maybe that's a suggestion. Hey, do you want to make the bedroom a little bit smaller? And I think it's also from an ML perspective also totally doable. Yeah.
That's awesome. And I I would move a bit into some non-technical questions
Very
about
good.
this. So uh, my first is like, if you had like unlimited time and resources, what
Mhm.
are the things you would like to work or develop?
Whoa. I think what's also very interesting is mm, yeah. So I've got this idea that like in the AAC industry we focus a lot on generating things. So whether you use Grasshopper or Revit or whatever, we all generate like structured data, and I think it would be cool if someone would focus on also not only generating structured data, but actually trying to automatically obtain structured data. So like, rather than, or the idea that you can kind of generate a Grasshopper script from a 3D model, or that you can automatically find blocks within your file. And the idea behind it is a little bit that like often when we interact with documents within AEC, like the documents or the data is not really perfectly structured. So like all the repetition within the file is not often found just because maybe the nature of the data is not perfectly structured, such as a point cloud, or you imported some DXF or whatever, and there's just the repetition is not defined as blocks. It doesn't really matter, but I think the point is that often the data is not perfectly, or the repetition is not always found. So if somebody could make like a hierarchical clustering algorithm of existing documents, then you can become very powerful, because then you can say like you can do new commands such as select similar to this one, or automatically create blocks or whatever, and then you can be much more powerful, much quicker. And I think because often like in architectural design or in buildings, there's so much repetition, and I feel like sometimes we can leverage that even more. That like if you're working on a hospital and you're working on some sort of patient's room and you have this patient room for 20 times, then if you move one bed in one patient room, it would be cool if the algorithm can suggest, hey, you're working in a cluster which is similar to other clusters. Do you want to move the bed in all these other rooms as well? So something like that would be really cool. It's
That's
probably
super
quite a lot of work.
interesting.
So yeah, yeah,
That's not a hackathon project, but that's one could always
yeah,
try.
yeah, yeah, exactly. Yeah,
It's amazing. And I would do like a rapid fire round, and if
cool.
you may want to like stop sharing. Yeah,
Yeah,
perfect. So yeah, basically you'll have like 30 seconds to answer those questions,
damn. Okay.
and it should be brief. So all right, Jeroen, which city is in your travel bucket list?
Um, good one. Sydney, Australia would be really cool. Yeah.
I see. What are uh, technical or business books which made a big impact in your life?
I like, it's not really a business book, but I like the Sapiens book of Harari. I thought it was super cool, super nicely written history of humankind. Super cool.
I see. Uh, who is your role model?
Wow. I like that the CEO of Comma.ai, George Holt. He's like a real hacker guy. Super strange, but really cool, and yeah, really cool personality. So yeah.
I see. Any mentor or teacher who made a big impact in your life?
Yeah, when I was studying computer science, I mean, I was such a noob and I was doing everything wrong. So it was, I mean, basically all the tutors there, they really changed my perspective for sure.
I see. What's your favorite architectural or urban place?
Oh wow. Let me see. Oh, why cannot I not answer this? um, I mean, I really like Hedderwick, but Thomas Hedderwick, the architect, the British architect. But I mean, he has so many great buildings. Uh, I really like the new building he did in South Africa. So it's like a hotel. It's really cool. It's out of a kind of existing silo. He kind of sculpts like a whole new volume. It's super cool.
I see. And what are your hobbies?
Yeah. So my main hobby was skateboarding. So I really like skateboarding, but now my knees are a little bit rusty. So like I cannot jump like 10 stairs anymore, sadly. But I watch skateboard movies all the time, so it's super cool. Yeah.
That's awesome. Are there any like movies or influencers who you follow?
Yeah, I mean I follow. Yeah, I'm like not that active on Instagram, but actually I was on TikTok, which I really like, but it's so addictive, so I don't recommend it. But I really like Trevor Wallace. It's like this. He's kind of comedian. He's super funny, guys. So I can totally recommend you to follow him on YouTube.
Got it.
Yeah.
And is there anything you wish you have done differently?
No, I mean, I don't think there's so much point in thinking about like or having regrets. I just think like you have to learn from, or you have to, yeah, you have to try to make in the future the best version of yourself. So yeah.
Got it.
Yeah.
And what is your piece of advice to young professionals and students who
Mm.
who wants to get into software development or AI or application development?
Mm. Yeah, so have a project where you can work on, and don't be afraid to ask anyone for help, because I think most people are really happy to help. There's lots on Stack Overflow, but also on Discord or something. You can always also ask people personally. I mean, if people want to ask me personal questions about development, they can always ask me. No problem.
I see. And what is one thing that excites you the most when you wake up?
Oh, let me see. What excites me the most? I think coffee. Yeah, so if you have like a really big cup of coffee, that's super nice in the morning for sure. Yeah.
All right. My last question is like, is there anything which we didn't cover in this interview and you like to share?
Yeah, so don't download TikTok. I think that's a really good advice as well. Because I had it for a few months, and I was like looking at my usage of my iPhone, and I used it so much. So they're like so addictive. So really don't use it. Don't use it. That's my advice. Yeah.
Yeah, like it's definitely very addictive. Even now
Yeah.
Instagram has reels, so
I
it
know. I
has the
know.
same effect.
Yes, it's really bad.
Awesome. It was a great session. I loved all of your work, the approach, and
Cool.
like it looks very simple and intuitive on the interface, but I could only understand like how much difficult the engineering and the pipeline and the integration was. So commendable job, and I'm very impressed like you did it in such a short time span and with those resources. Like great work, Jeroen. Good luck in this journey.
Yeah, thanks a lot for having me, and I hope we can talk another time in the future.
For sure. See
Cool.
you.
All right.
Bye bye. Have
Thanks.
a good rest of your day.
You too. Ciao.